Hello friends, today I will solve a LeetCode medium problem on arrays. So the problem is minimum increment to make an array unique. So we are given an integer array nums. In one move, we can pick any index I and increment nums up by 1. So we need to return the minimum number of moves to make every value in nums unique. So let's consider the first example. You can see the nums array is 1, 2, 2. So if we increment the last 2 by 1, the value becomes 3. So at the end, we can see the array becomes 1, 2, 3, or after one move, the array becomes unique. So the output will be 1. So let's understand this problem with given examples. So here I have taken the first example. The nums array is 1, 2, 2. So first I'll sort the nums array. That is, nums array will be 1, 2, 2. Then I'll declare another variable called next unique value. So after sorting, first element in the nums array will always be part of the result. Then I'll go to next index. Here I can see the value is 2, which is greater than the next unique value. So I'll update the unique value to 2. Then I'll go to next index. So here the value is 2. So this value is less than equal to the next unique value. So the next unique value will always be an increasing sequence. So the current value is less than or equal to next unique value. So I'll increment this value by 1. The value is 3. Now you can see this value is less than the next unique value. So I'll update the next unique value to 3. And as I'm doing here only one increment, so the result will be 1. Similarly, let's consider the second example. So first I'll sort the nums array. So I'm sorting the nums array because I want to traverse the elements in increasing order. So initially next unique value will be assigned to nums 0, that is 1. Now I'll consider the next element. Here the value is 1, so which is less than or equal to the next unique value. We need to increment this value by 1. We'll increment to 2. The number of moves will be 1. Then I'll update the next unique value to 2. Then I'll go to next index. Here you can see the value is 2 here, which is equal to the next unique value. So it is not unique anymore. So I'll increment the value at current index to 3. So I'll increase the move. Now I can see the current value is greater than the next unique value. So I'll update the next unique value to 3. Then I'll go to next index. Here I can see the current value is 2, which is less than the next unique value. So I'll increment it by 1. I will increase the moves by 1. So here the current value less than equal to the unique value, next unique value. So I'll again increment it by 1. So the value will be 4. Now this value, the current value, it's greater than the next unique value. So I will change the next unique value to 4. And I will increment the number of moves by 1. Similarly, the next value is 3. I can see the current value is less than the next unique value, so I'll increment it by 1 and I'll increment the moves by 1. So the current value will be 4 and the current value still is less than equal to the next unique value. So 4 is not greater than the next unique value. So I'll increment it by 1. So the current element will be 5 and the number of moves will be 1. So now 5 is greater than the next unique value. So I'll assign 5 to the next unique value. Here the current element is 7, which is greater than the next unique value. So I will update the next unique value to 7. So in this case, let's say the next values was 10, 11. Here the next value will be 10. So I will update the next unique value to 10 because 10 is greater than the next unique value 7. Similarly, I will go to here. I will see 11 is greater than the next unique value. So I will update it to 11. So here the result will be 6. You can see the next unique value sequence is always an increasing sequence. So at the end, array will be in increasing order, which is same as the unique value sequence. So for example, if the current value is 5 and the next unique value is 10. So we need to increment 5 such that the current value becomes greater than the next unique value. So we know that 10 is already used. So we need to increment 5 to 11. So I can directly say the number of moves will be next unique value minus current value plus 1. So I will not increase the current value by 1 in a for loop. I can directly say the number of moves will be next unique value minus current value plus 1. So what I will do, first I will sort the array. So sorting the array allows us to traverse from the smallest element to largest element in the array. And second, for each element, calculate the number of moves and update next unique value. So now I will code the solution. So first I will sort the array. Then I'll declare a variable called next unique value. That is equal to the first element in the nums array. Then I'll declare a result variable. Then I'll start from the first index, I equal to 1, I less than length of the array, I plus plus. If the current element is less than equal to the next unique value, then I'll add the number of moves because we need to increase nums of I to next unique value plus 1. So the number of moves will be next unique value minus the current element plus 1, and at the end, so I'll just increment the next unique value. Else, if the current element is greater than the next unique value, so I will update the next unique value to nums of I. At the end, I will return the result. So now let's run it for the sample test cases. Sample test cases are running fine. Now I will submit it. So you can see it's working as expected. So here, first I am sorting the array. So then I am linearly traversing the array and I am accumulating the result and updating the next unique value. So we can say the time complexity will be big O of n log n. So here, if you see the constraints, we are given the length of the array is 10 to the power 5. Similarly, each value in the nums array is at max 10 to the power 5. So instead of using library sorting algorithm, we can use counting sort based approach. Now I will discuss another approach that is based on counting sort and uses the above idea. So I have taken the first example. So what I will do here, I will declare a frequency array of size max element plus n. So max element is the maximum element and n is the size of nums array. So here the max element is 2. So this is the frequency array of size 5. So first I will traverse the nums array and I'll increment the frequency of each element. So the frequency of 1 is 1 and the frequency of 2 is 2 and all the other frequencies will be 0. Then I'll declare a result variable stores total number of moves required. So I'll linearly traverse the frequency array. The frequency of 0 is 0, so I'll ignore it. Similarly, I'll go to the next index. You can see the frequency of 1 is 1, so I'll go to next index. Here you can see the frequency of 2 is 2. So we know that in the nums array 2 is present 2 times, and at the end nums array should be distinct. So I'll increment value of this 2 to 3. So I'll calculate a variable called overflow. So the overflow will be 1 occurrence of 2. So I'll update the frequency of 2 to 1. Then I'll add the overflow value to the result. Then I'll go to next index. So here the overflow is 1. So it means one element is increased from value 2 to value 3. So I'll add the overflow value to the current frequency. So the frequency of 3 becomes 1. Now I'll go to next index. Here the frequency of 4 is 0. So I'll stop the loop. At the end, you can see in the frequency array, the value of the frequency of 1 is 1, the frequency of 2 is 1, and the frequency of 3 is 1. At the end, the nums array will be 1, 2, 3, and here all the values in the nums array are distinct. So we just need only one move to make all the elements in the nums array distinct. So let's consider the second example. So here the max element is 7 and n is 6. So now I'll traverse the nums array and I'll update the frequency of each element. So you can see the frequency of 1 is 2 because 1 is present 2 times in the nums array. Similarly, the frequency of 2 is 2 because 2 is present 2 times in the nums array. Frequency of 3 is 1 and frequency of 7 is 1. So I'll start from the first index. Here initially the overflow will be 0. The frequency of 0 is 0. So I'll go to next index. Here the frequency of 1 is 2. So we know that there are two ones in the nums array. So value of this one will remain same. The value of next one, we need to increment it by 1. So here the overflow will be 1. I'll add the overflow value to the result. Then I will update the frequency of 1 to 1. Next I'll go to next index. Here you can see the overflow is 1. It means from the previous index, one occurrence of value 1 is increased to 2. So first I'll add the overflow to value 2. So the frequency of 2 becomes 3. It means now there are 3 2's in the nums array. So it means we need to increase the value of these 2's. So I'll update the overflow to 2 and I'll update the frequency of 2 to 1. I'll add the overflow value to the result. Then I'll go to next index. So now I'll update the frequency of 3 to 1 plus overflow value 2, that is 3. So it means there are 3 3's in the nums array. So we need to update the frequency of these two 3's. So now the overflow becomes 2. So I'll add the overflow to the result variable. So this means there are 2 3's, so whose value needs to be increased. So next I'll go to next index 4. Here the frequency of 4 becomes 0, the current frequency plus the overflow. So it becomes 2. So it means there are 2 4's in the nums array. This 4 needs to be increased by 1. So the new overflow value will be 1 and the frequency of 4 becomes 1. Then I'll add the overflow value to the result. Then I'll go to next index. I'll update the frequency of 5 to 0 plus the overflow value, that is 1. It means there is only one occurrence of 5 in the nums array. I'll go to next index, that is 6. The frequency of 6 is 0. Similarly, I'll go to next index. The frequency of 7 is 0. So here now the overflow becomes 0 because there are no overflows. Similarly, I'll go to next index 8. The frequency is 0. So the overflow is 0. Similarly, I'll go to index 9, 10, 11, 12. I can see all the frequencies are 0. So at the end, the total number of moves will be 6. And you can see in the frequency array, the frequency of 1 is 1. Similarly, the frequency of 2 is 1. Similarly, the frequency of 3 is 1, frequency of 4 is 1, and frequency of 5 is 1, and frequency of 7 is 1. So you can see the resulting nums array is distinct, and the resulting nums array is constructed from the frequency array. So now I will code the solution. First, I am declaring a variable called max element that is initialized to int min. So for each num in the nums array, I will update the max element to max of the current max element and the num. Then I will declare a variable n, that is nums dot length, length of the nums array. Then I will declare a frequency array of size max element plus n. So for each num in the nums array, I'll increment its frequency. So now I'll traverse the frequency array. If frequency of I is less than equal to 1, then I'll continue. Else, I'll count the number of duplicates, that is frequency of I minus 1. So duplicate is same as the overflow variable we discussed before. Then I'll update the frequency of current element to 1, and I'll add the duplicate or the overflow to the next index, that is frequency of I plus 1 will increment it by the duplicates value. Now I'll update the result variable. At the end, I'll return the result. Now let's run it for the sample test cases. Sample test cases are running fine. Now I will submit it. So you can see it's working as expected. So here what we are doing, we are first finding the maximum element. So this is a linear step, or big O of n. Then we are allocating a frequency array of size max element plus n. So it is big O of 10 to the power 5. Let's say the max element is 10 to the power 5 and n is less than equal to 10 to the power 5. So we can say this is big O of 10 to the power 5. Then for each element in the nums array, we are incrementing the frequency. So this is big O of n. Then at the end, we are linearly traversing the frequency array and doing some constant number of operations. So this is also big O of 10 to the power 5. So we can say the time complexity is big O of 10 to the power 5, which is greater than or equal to big O of n. So we can say the time complexity is big O of 10 to the power 5 when the max element in the nums array is 10 to the power 5. So on average, this approach works faster than the sorting based approach we discussed before.